Hi all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to see deep into the topic what is process synchronization. So before actually seeing what is process synchronization, first let us understand there are two types of processes that are being executing in the system. Now let's see the picture here. So when you look into the first half of the image or the picture, you can find a person who is currently working with his laptop. He might be doing something with the laptop using a word processor. He might be typing the document, as well as at the same time he is listening to music. When you look into the second half, you can see two persons. One might be a team leader and the other one might be her teammate. So they are deeply discussing into the topic of study. So now I hope this will be very clear for you. So when you look into the first thing, this man will not be affected by anything because he is not sharing his resources with others. So he is not going to be affected or will be affecting other processes in the system. Whereas when you look into the second thing, they are going to share the resource, they are going to be affected, they will be affecting. So all this chaos may happen in a cooperating process. So to avoid this chaos only, we are taking as a process synchronization. So an independent process is nothing but it is a process in which that cannot affect or it can't be affected by other processes executing in the system. So another type of process, as we discussed earlier, is the cooperating process. A cooperating process is one that can affect or be affected by other processes executing in the system. So when you take cooperating processes, it can either be directly sharing a logical address space, or it is allowed to share only a shared data or a file or a database through files or messages. So what happens in the cooperating process? So the cooperating process will try to affect the other processes in the system. So what happens? The major disadvantage of the cooperating process, when they are concurrently accessing a shared data or a shared resource or a shared file or a shared database, it results in data inconsistency. So remember, when you have concurrent access to shared data, it may result in data inconsistency. So there you should bring process synchronization. So how to bring process synchronization? So when a cooperating process that shares a logical address space, the data consistency is maintained. So to maintain the data consistency, we have to have the orderly execution of the cooperating processes which are trying to access the same shared data simultaneously or for a concurrent access. So this can be prettily explained using the producer-consumer problem. So we all know what is producer-consumer problem, or we can also call it as bounded buffer. So what do you mean by producer-consumer? So whenever a producer process is working, the producer will produce an item and store it into the shared buffer space or the shared memory. Whereas a consumer will consume an item from the buffer. So this is your producer-consumer problem, and why it is named as bounded buffer? Because we have a very limited memory space. That is why it is called as bounded buffer or the producer-consumer problem. So here initially we will have a counter variable to explain this producer-consumer. So counter variable is nothing but your buffer. Think it as a buffer space. So whenever a producer process produces an item, the counter variable should be incremented by 1. That is why it is given as counter plus plus. Whenever a consumer item consumes a process, that is a data item is removed from the buffer, so we have to decrement the counter variable. So counter minus minus is given. So let us understand this with an example. Suppose we have the value of the counter variable, that is currently the buffer size or the counter variable is currently 5. So now think that the producer and the consumer processes execute the statements counter plus plus and counter minus minus concurrently. That is, concurrent access is nothing but a simultaneous access. So there is no orderly of execution. Whichever comes first, they will be doing it. So think like the producer process and the consumer process execute the statements concurrently. Both the process try to access the variable count. So if the execution of these two statements is done, the value of the counter variable might be 4, or it could be 5, or it could be 6. Depends upon whether, if it is 4, the consumer process might have taken prior. If it is 5, it is doing perfect. If it is 6, the producer process has taken into effect first one. So in this example, if the counter variable is currently 5, and if the producer process is going to execute first, and then an orderly execution of the consumer process is done. That is, when a producer produces an item, the consumer should consume an item. This is very clear, right? So if that has happened correctly, if there was an orderly execution of that statement perfectly, the correct result of this producer consumer problem would be generated as 5. But if the producer and the consumer process does not synchronize properly, it will lead to a very hazardous situation, which is called as race condition.